Alright, welcome to Majestic Tutorials. Here I'll be handling GCE titration question. Remember to check the video on SALT analysis, that's qualitative analysis. Here I'll be handling quantitative. We'll go through the questions that we are going to be expecting and how to tackle it, the best way to provide the correct answer. Here is the type of question you will see. Remember, you are not going to do titration because it's alternative, like you can do the real practical but answer questions that follows it, but they will provide those basic information. Actually, what you get from titration is endpoint, and you have seen the table from where you can determine your endpoint. So these are the questions. I will handle two likely questions and then wait for you on the live stream depending on your comments before the exam for us to discuss finally. As you enjoy the class, don't forget to subscribe and share with others. Thanks for having you. Then expand us by sharing and give us your comments. Give this video a thumbs up. I believe it's going to be very helpful at the end of the day if you listen well. Okay, over here I'll be handling these questions. So they say E is prepared by dissolving 33.60 gram of a mixture of iron 2 sulfate heptahydrate, and sodium chloride to make 1.0 dm cube of solution. F was 0.02 mole per dm cube KMnO4. Then 25 cm cube of E was pipetted into a conical flask, acidified with 20.0 cm cube of dilute H2SO4 and titrated with F. The results are recorded in the table below. So they have given you table. Your job is to copy and complete question AI. Now said copy and complete the table, calculate the average volume of F used. They give us the equation of the reaction. This type is redox titration, so I'll do one redox and do one acid-base titration like I've shown you. Now I will fill the table here and then I'll go to my notes where I'll solve the rest of the question that follows it with detailed explanation. Okay, looking at what is here is final reading. They gave us values, so we have to fill here, here, and remember to follow the rules. Even though they omitted, they say burette reading, they say cm cube, so it has covered. Since cm cube is here, it has covered every unit here, but to stay on safer side you can still put cm cube, but that's not filling the table. So this is final, this is initial. So how do you now get, and this is the volume of F used. So to get what should be here, we need to minus exactly what? We just need to say, of course, 33.10 minus 23.50. Whatever it gives us is the answer, of course. So we have that. To find what should be here, mathematically, simply 33.10 minus 23.50, maybe we have 33.10 minus 23. Shockingly, I've forgotten. Minus 23.50, I guess. This is giving us 9.60. So we go back. 9.60. So I was correct. Remember to write this 0. Don't just write 9.6. You will lose mark. Keep it in 2 decimal places and then 3 significant figures, possibly when you want to get your concentration. You follow the same pattern. The idea here is that for you to get this volume of A used, you have to minus final burette reading from the initial, which is 9.6. So now this is very simple. Our initial was 7.50. The final here was 30. We record initial first before final, but in writing we write final before initial so that the maths will be easy for you. So normally, what do we have? 30 minus 7 is 23, but he removed another 0.5, so it's going to be 22.5. That should be here, if I'm correct, of which I know I am. This one, they didn't give us what is here. To fill in this gap, you always minus from the smaller, and minus the smaller from the bigger one, but not when you are giving this volume of AUs. So this was the answer gotten. You sum it up here instead. So we will call here x, for example. So remember, x plus 2.4, x minus 2.4 gave us this. So let's do math. X minus 2.40 gave us 22.60, such that x is now what? 22.60 plus 2.40, such that we have 4 gives us whole number. So we have 25. Yes, it's giving us, because 22 plus 2 is 24 plus 1 is 25.00. Make sure to put it. So x is 25.00. Put 0.00. So that when you minus it, you get this 22.4. If you minus 25.00, if you minus 22.4 from it, you will now get 22.60. Okay, we are done with filling the table. The next, we are finished completing the table. The next one will be very simple now. We have to, they say, copy and complete. This one is done. And the next is I calculate the average volume of F used.
Are you looking for a trusted supplier of medical equipment, science equipment, and reagents? Search no more. Choose Her Majesty Easy Word Science, where you buy directly from the scientists who understand the quality and the working principle of every tools and analytical reagents. We don't just sell, we guide you. Do you know that every purchase comes with free practical guide on how to use the reagents or apparatus effectively by a scientist and experienced medical experts? We are majestic, reliable, and affordable. We say to you exactly what you ordered. This is not what you ordered versus what you got, because the satisfaction is our watchword. Thank you.
Wait a minute. Have you heard about the Majestic Table? It was designed and recommended by Her Majesty himself. Yes, it is. The amazing thing about the Majestic Periodic Table is that it provides a clear and colorful classification of elements, from P block metals to metalloids to liquid metals. It also shows the boiling and melting point of all the elements. It also has the unique feeling of electrons in the shells of each element.
We need a working sheet here, so permit me to divide the screen. The question. Secret on how to do this, you will also learn that we have two formulas compulsorily that we will, that let me not say compulsory, but about 80% possible you must use. This formula, CAVA over CBVB equals NA over NB. But in this question, they are speaking in terms of what? E and F. Therefore, we will have CEVF in that order, because they are talking about F now. But remember, it's the same thing. Then another formula is knowing that molarity, knowing how to relate molarity. Okay, I need to increase maybe. Yeah. Relating that molarity is equal to mass concentration all over molar mass which in unit means that mole per dm cube is equal to gram per dm cube all over gram per mole. So this formula should be in your head. Then another secret, you go to the question, this statement, know what E is. Don't joke with the information. What did they tell us E is? E is 33.60 gram in what volume? In 1 dm cube of what compound? This compound mentioned. The same thing, you pick that fact about F. So we will keep it at the back of our mind. We will be using it. The next one says calculate the average volume of F used. This one is now going to be based on this table anyway. Sorry, I think I will do it on this table side so that you get it. Average volume of F used. We are going to use concordant titers. I cleaned here unknowingly. I've written what is here as 22.50, I guess. Yeah. So average volume of F used, you have to check these figures and know the ones that are concordant. This is 22.50. This is 22.60. So these two are concordant. Okay. We can see that they are concordant titer values, because they did not vary with more than 0.1 or more than 0.2. Okay, 23.50 is off. I've cleaned what I feel there, but it should be 9 point something. So 23.50 is off because it's 1 cm far away. So the correct value is use at least two values that do not vary with more than plus or minus 0.2 at least, but the best is plus or minus. Use the one that do not vary with plus or minus 0.1. That's what we call concordant titer. So looking at this table, the concordant titer values, say average volume of F, you write VF is, you write 22.50 plus 22.60 all divided by 2. What if this one is concordant? You can use them. Let's assume this is 22.50. You will now add 22.50, 22.50, and 22.60 because 3 of them are within the range of 0.2. Okay, but here we have only 2 to be used. Now you have that VF is equal to, at the end, you remember to show your working, but I will skip a stage and give you the final answer. The final answer is going to be 22.55 cm cube. That's our VF. Okay, then the next question, I summed these two numbers and divided by 2 in case if you are confused. The next question said they gave us the equation of the reaction. As you can see, it's a redox reaction. So this is where we know the mole ratio of E, which is 5. The mole ratio of F is 1 because the coefficient here is simply 1, but here the coefficient is 5. So we go and solve. From the result and information provided, calculate the concentration of iron 2 tetraoxosulfate 6 heptahydrate in E in mole per dm cube. You go back, remember that this 33.60 gram was a mixture, is impure, so you can't use this. It's mixed up with iron 2 sulfate and also sodium chloride. But since this is a redox reaction, the sodium chloride will only be detected by KMnO4. Okay, will only be detected by KMnO4. But the challenge here practically is that this KMnO4 will be acidified, and there will be little tendency that the H2SO4 will attack this sodium chloride to liberate some steamy fumes or HCl, but no problem anyway. I don't think this is a suitable impurity in this reaction, but they are assuming that it needed heat. Of course, it needs heat for that one to proceed sideways, but they could have brought something that will not react with KMnO4 because H2SO4 might attack the sodium chloride to liberate HCl, which will still start reducing this KMn. Okay, but that's just by the way, that's for those that are advanced a bit. But take it that they are asking you impurity. Here, it is assumed that only iron 2 sulfate will react with this. So this iron 2 sulfate and sodium chloride weighed 33.6. Out of this 33.6, how do we now know the pure mass of this iron 2 sulfate? The one that will now be consumed by this KMnO4. And they gave us KMnO4 is a standard solution, 0.0200 mole per dm. This is known, but this we don't know it. And that's the one they tell us to calculate, E. Okay, so you are going to go back to the formula now. I want to change. I'm going to be changing this now to adapt to how they used it in the question. So instead of CAVA, I'll be using CEVE because the letters here is E and the F, not A and B. Okay. So from the formula, CEVE equals CFVF equal to the mole ratio of E is 5. Look at it here. While the mole ratio of F is 1/1. Then, what you will not do is to start solving without making subject of the formula. We are looking for CE. So you tell the examiner that CE is equal to, you cross multiply. In that process, you have that CE is equal to CF VF times 5 all over VE times 1. You start solving. If you don't do subject of the formula and solve, you lose 1 mark. Like if you start doing your substitutions using this formula you stated without making the CE you are looking for subject of the formula, you lose 1 mark. So don't be a victim. Time to plug in our values. What is CF? CF is the concentration of F, molarity of F, which was stated clearly as 0.02. So we say that CE now is equal to 0.02 times, what is our VF? Volume of F. What we got as our average now. VF is 22.55. That's it. Okay. 22.55 times 5 all over VE, that's volume of E, which is 25 times 1. So we do correct substitution. If you wrongly evaluate your answers here, mathematical error, what we call AE, arithmetic error, you still lose mark. So you carefully press the value we have, 0.02 times 20.5 times 5, okay. 0.02 times 22.5 times 5 is equal to 2.50. 2.250 divided by 25. 2.250 is 0.09. 2.250. So we have 2.250 divided by 25 give us 0.0. Make sure to leave in 3 significant figure, but I don't see the possibility here. We are just getting but 0.099. and just complete it. 0.0900. 0.090 mole per dm cube. Put unit, no score, or you lose 1 mark either. Don't say is it not just 1 mark, you'll be losing it gradual. So we are done with I. Then I said concentration of iron 2 sulfate in gram per dm cube. We are now done solving in mole per dm cube. We are going to now convert in gram per dm cube. Time has come for us to use this formula over here. This formula is going to come in use, okay? So maybe I'll drag it down here. as I try to take this one up. Okay, so this is the formula that we will use. Why it will work out well is that we have seen the compound in question. They said iron 2 sulfate decahydrate, the mass concentration. So mass concentration, that's concentration in gram per dm cube, is, you can now make this one subject to the formula, so that gram per dm cube is equal to mole per dm cube. Gram per dm cube is equal to, no, gram per dm cube is equal to, yeah, mole per dm cube times molar mass, that's gram per mole. And the gram per mole is already gotten at 0.09. They're supposed to give us the molar mass of this iron 2 sulfate, but we have to calculate it now. It will take us time, but careful, watch we do that. Iron is 56, but the question, they will give it to you in exam. Iron is 56. What am I doing now? I'm determining the molar mass of iron 2 tetraoxosulfate 6, the molar mass. So looking at the next thing, the molar mass of FeSO4.7H2O, the molar mass of iron is 56 plus 32, sulfur is 32. I'm supposed to give it, oxygen is 16, that's molar mass. That's 16 times 4 is 64, plus 7 times 18. Where did I get 18? The molar mass of water is 18. So mathematically, 7 times 18 is 126. So we are looking at 56 plus 32 plus 64 plus 126. Accurate calculation, we will have that. We might do horizontal addition without wasting time pressing calculator. Okay, let's go. 6 plus 2 is 8. 8 plus 4 is 12. 12 plus 6 is 18. So we write 8 first. 8 is there. 18. 8 carry 1 and come to the next value. Add this one, this 5 becomes 6. 6 plus 3, 9. 9 plus 6, 15. 15 plus 2 is 17. You write 7 and then carry the 1 to here to make it 2. So it becomes 278 as the molar mass. Okay, but for benefit of doubt, since there is calculator here, I use it. 56 plus 32 plus 64 plus 126 is 278 gram per mole. So it becomes easier for us to convert. I think we have to go to the next page. So our molar mass of F, if I'm correct, no, of E is equal to 278 gram per mole, such that mass concentration now, that's gram per dm cube, will now be 0.09 times 278, which is the molar mass. So we simply say here times 0.09, which is 25. All right, 25 gram per dm cube. 25 gram per dm cube is the concentration in gram per dm cube. The next question here says the percentage by mass of iron 2 sulfate heptahydrate in the mixture. Remember, that's where you now see the number here. This is where this number will work. 33.60 is both that iron 2 sulfate and sodium chloride. So they are now asking us the percentage by mass of the iron 2 sulfate. Simple. Total mass of impure is what? Total mass of impure sample, that's the one given, is equal to 33.60. But the pure sample that participated in the titration is 25. So out of the 33 provided, that's the pure sample of iron 2 sulfate heptahydrate. So then the mass of pure is equal to the mass concentration. So mass of pure FeSO4 7H2O is 25 grams. So the impurity, it is easier now to calculate mass of impurity. Mass of impurity is now mass of impure sample minus mass of pure, which is 33.60 minus 25 gram. So this way 33.60 minus 25 give us I didn't put 33.6 minus 25, 8.6 is the mass, 8.60 gram. Then looking at the percentage by mass, although this impurity we don't even need to solve it, I just solved in case for teaching, because the question demands we just find the mass of sodium, the percentage by mass. We take the mass, the gram per dm cube, divide by the total mass times 100 over 1. Total mass is 33 point what? So percentage by mass of iron 2 tetraoxosulfate 6 heptahydrate is, take the mass, the gram per dm cube of it, over total mass, which is 25, times divided by 33.60 times 100 over 1. So 25 divided by, at least it's more than, it's going to be close to 80%. 25 over 33.60, 25. Oh, it's not close to 80, 74.4% times 100 is 74.4%. To a significant figure, anyways, 74.4%. Okay, the next question say explain, that's question C. Explain briefly why hydrochloric acid cannot be used to provide an acidic medium in the titration involving KMnO4. I indirectly explained it when I condemned sodium chloride as an impurity because of the possibility of H2SO4 displacing HCl from sodium chloride, which will react with this KMnO4, of course reduce it. Is also a reason. So your answer here is simply, they say explain briefly why hydrochloric acid will be oxidized by the KMnO4, as the hydrochloric acid itself is a reducing agent. So briefly explain. Our brief explanation is that the hydrochloric acid will be oxidized by the KMnO4. The hydrochloric acid will be oxidized to chlorine. There will be liberation of chlorine by the what? KMnO4. Remember, the acid is needed to provide the acidic medium, that's to protonate the medium, not to react with the other. So HCl is not suitable. The suitable here is H2SO4. Like this H, acid is the source of this hydrogen ion you are seeing in the redox equation or the ionic equation. Understood? So even though hydrochloric acid will tend to provide this medium, but unfortunately it will undergo another side reaction, which is to start reacting with the KMnO4 instead of providing this medium needed. So H2SO4 is the suitable because H2SO4 is not a reducing acid, unlike HCl. H2SO4 is also oxidizing and will not be attacked by the H2SO4. So it's the suitable and will not be attacked by the potassium tetraoxomanganate 7, please. So the suitable acid for this is H2SO4. Why? Because it's not a reducing acid, unlike hydrochloric acid. Now, explain why the upper rim of the meniscus is red in KMnO4. Upper meniscus. This is practical-oriented question. You know, when you pour liquid in the burette, permit me to maybe draw something that might represent our burette. Okay. So, with tap, of course. The tap is not our interest. And as burette, it will be calibrated. So, the calibration shown. Then, this liquid, the color of that is purple. So the KMnO4 is purple. So this diagram will explain everything. So when a liquid is in burette, it forms curve. So this curve is where our interest, this curve. Now they are telling us we have the lower lip. I want to expand this for you to see where. So this curve, this is the upper meniscus, while this is the lower meniscus. This is lower, while this is upper. So while reading this KMnO4, you take the upper. Why? Because it's colored, it's invisible. The lower meniscus is invisible. Simple. The color of the KMnO4 covers the lower meniscus. That's what you say. Because the color of the KMnO4 will cover the lower meniscus such that it will no longer be visible. So how can you now take the reading of what you cannot see? So you can't see the lower meniscus. Rather, it's the upper meniscus that is visible. So for colored contents, you take the upper meniscus. But for transparent contents, you're advised to take the lower meniscus. But remember, that's why the accuracy reading allows plus or minus 0.1. So this thing is insignificant. I don't even know why they are stressing people, since we still permit 0.1 error and the accuracy of precision. So there is it. I've explained that one. Then the other one says, why was no indicator used in the titration? Because it's a redox titration whereby the color change of the titrants and the analytes determines the endpoint. Indicator is not needed because the KMnO4, the color change in the KMnO4 shows complete reaction. When the KMnO4 turns from purple to pink, or when the iron 2 sulfate becomes yellowish or reddish brown or amber, not reddish brown at all, pinkish or amber color, we now know that neutralization is complete. So
that's 22.12. That's 22.2.
Yeah, I go to the next one.
1, 2, 3, 4. That's 5. That's 2.5.